Good afternoon. I, Puneet Gupta, lecturer in computer engineering at GPCG Patiala. I am here to present my lecture on memory management. It's a part of an operating system. It's an important function of an operating system. Before start the lecture, I just want to give the brief introduction about the memory. How we use the memory, what is it used, why we need it. Memory is a storage device where we store the data which we want to retrieve after some time. The data which we want a day after the tomorrow or after some seconds, we need to store it somewhere, that is called a memory. Without memory devices, we are not able to regain the data. Memory is also necessary to execute the programs in the system. If memory is not present in the system, we are not able to execute the programs. Now in my lecture, I am here to discuss how operating system manage this memory for the various program which have to execute in the system simultaneously at the same time. We have to provide the memory to each and every process, each and every program which I want to execute in the system. So the proper management of the memory is very much needed, and this is done by the operating system. Now start with the lecture. Operating system, as we know, the operating system is a set of master programs. It's a software which control the entire operation of the computer. It control the whole the system in which we are working. Operating system is a general purpose software which is involved in each and every activity of the computer. Each and every activity, each and every work of the system is done by the operating system, directly or indirectly. The various functions of the operating systems are interface between user and the hardware. Second one is a peripheral management, and third one is a memory management. Fourth is a process management. Here in my lecture, I am here to brief about the memory management, how operating system works to operate the system in the memory, how operating system manage whole each and every unit of the memory for proper utilization. Before start to the memory management, we just give a brief introduction about the memory. What is a memory? Memory refers to a physical devices used to store the data temporary or permanent. If I want to store the data anywhere in the system, then I need a physical device, that is called a memory. There are the two major kinds of the memory. First one is a primary memory and second is a secondary memory. The primary memory is the main memory of the system. It's also called the internal memory of the system. Without the primary memory, we are not able to execute any program. Even we are not able to start the system. It is very fast memory. The two kinds of the primary memory are the RAM and the ROM. RAM is a random access memory. It's also known as a main memory, and it's hold the data for the temporary basis. And ROM is a read-only memory. The main BIOS system, the operating system, all the major files which are used to run the system are permanently stored at the ROM. Now the secondary memory. Secondary memory are the physical devices to store the program and the data, and these are the secondary memories as there is no need of the secondary memory in the system. But if I want to higher the capacity of my memory, I want to store large amount of data in my system, then I need a secondary memory. As a primary memory has a limitation of 1 GB or 2 GB, the secondary memory starts from the 2 GB. It goes up to terabytes. There are some of the memory units which go up to the terabytes. It's a unit of the memory to hold the data. It's equivalent to 1024 gigabytes, and they are very slow to access, but they have a higher memory capacity. The examples of the secondary memory is tape, the magnetic tapes which are used in the previous systems. Magnetic discs are there, and after that there is a optical disc which consists of CD, DVD. A CD contain a data of up to 500 MB, and a DVD consists of data of 4.7 GB. So it start from the 4.7 GB, it goes up to the 16 GB. There is after that there is other devices who hold the memory in the terabytes. Now the basic principles, basic aims of memory management, why we provide the system memory management, why we do the memory management. The first one is to provide the memory space to enable many processes to be executed at the same time. In the multi-programming operating system, in a multi-programming system, the large number of processes are running at the same time. We have to provide the memory, we have to provide the memory space to each and every process which is executed at that time. So we have to done the memory management to protect the processes from each other. By using the memory management schemes, we protect the processes from each other. They can't contradict with each other, and each process like that they can running individually in the system. It provides a satisfactory level as performance to the user. It provides the greater performance to the system, to the user, as a number of applications are running at the same time. It make addressing of the memory space transparent from the programmer. The user, the programmer will use that system is don't know how these applications are going to the memory, and how these all programs are running by the operating system. The addresses, the where it is stored, it all transparent from the programmer. These are the basic aim of the memory management. Now address binding. Each program reside on a disk. A disk is a physical storage device or a secondary place where secondary memory where the data is stored. But if I want a program to execute, then this program has to brought into the main memory. Main memory is a RAM memory. The process has to move from disk to the memory, to the main memory. The different memory addresses are used at different location. At the tape or disk there is a different memory location, and at the main memory there is a different address location. The process of changing that addresses from disk to main memory, this process is called binding. There are three types of binding which are there. The first one is a compile time binding, second is a load time binding, and third one is a execution time binding. Compile time binding is done by the compiler. The compiler is a program, is a module which compile the whole program. It convert the physical address to the logical address by using the compiler. Load time binding is done by the loader. It also convert the address but at the time of the loading. And execution time binding is done at the runtime, and the execution time binding is done by the execution unit. Now the physical addresses and the logical addresses. There are two different types of addresses present in the system. First one is a physical address and second one is a logical address. We have to convert the physical address to the logical address and the logical address to the physical address. Now consider what is a physical address. The actual addresses that refer to the actual physical location of the main memory is called a physical addresses. The location, the place where our data is placed in the main memory is called a physical address. And the addresses generated by the CPU, the addresses which are generated by the CPU are called the logical addresses. And we have to convert that logical addresses to the physical addresses and physical addresses to the logical addresses by using that binding method. The logical addresses and physical addresses are same at the compile and the load time. At the time of compilation and the loading time, the physical addresses and the logical addresses are the same, but it differed at the execution time binding. At the time of running, the logical addresses differ from physical address. The mapping of logical address to the physical address is done by a hardware device, hardware unit, that is called a MMU, that is memory management unit. Now the next topic is relocation. The logical addresses are converted into the physical addresses by the help of relocation register present in the memory management unit, or is also relocated by the linker and the loader. The ability to load and execute a given program to the attributed place in memory is called relocation. The user program splice logical addresses must be mapped to physical addresses before they are used. The types of relocations are static relocation and the dynamic relocation. Now discuss these static relocation and the dynamic relocation. The two types of relocations are static relocation and the dynamic relocation. The static relocation is performed before or during the loading of the program into the memory. It's done during the loading or during the loading or before the loading of the program. It is done by the relocating linkers and relocating loader. But at that time the physical addresses and the logical addresses are same. So there is no need to convert the physical address or the logical address. There is no need to relocate the addresses, regenerate the addresses. But in the dynamic relocation, the dynamic relocation is performed during the execution of the program. It is done during the execution of the program and the running of the program. This is done by the help of a hardware support. A different hardware unit is necessary to done the dynamic relocation. This is called a memory management unit, MMU. And with the help of this memory management unit, we convert the logical address to the physical addresses. Now I show you how MMU convert the logical address to the physical address. Here a CPU which generate a logical address, that is a 346. 346 is any number. I just simply use 346, a number which a logical address, which a CPU generate to the generate a logical address for a program, that is 346. Now there is a MMU unit, that is a memory management unit. Here a relocation register which have the base value of 14,000. I just show it in the diagram. This is the base value of relocation register is 14,000. That 14,000 is added with the 346, and the actual physical address for the relocation for the logical address is 14,346. That is, we add the both the base address of relocation register and the logical address, then a final physical address is coming to us for storing the data into the memory, that is 14,346. Now the partitioning. The operating system manages the main memory by dividing the memory into the regions, into the various parts of the fixed or variable size, that is known as a partitioning, that is called a partitioning. It manages the main memory efficiently. The two types of partitions are static partition and the dynamic partition. Static partition, the whole memory is divided into fixed size frame. The whole memory, the entire memory, the main memory is divided into the fixed equal sizes, that is called a static partition. In the dynamic partition, we divide the memory into the variable size according to the page size given to the memory for the execution. Here we execute we divide the memory, we divide the partitions according to the size of the frame, according to the size of the page which is coming to execute into it, and this is called a dynamic. Now I show it with the example how a partitioning will work. Here we show a 4 processes, process P1, P2, P3 and P4. There are 4 different processes, and the space, the memory space it needed to execute is 10 for the P1 and 5 is for the P2, 18 for P3 and 7 for P4. I use a memory with a size of 50 and here I divide the whole memory in the static partition in the sizes of 10. In the static partition there is here is a static partition. Here P1 is start from the 0 and goes up to the 10. It hold the first 10 location in the memory. After that there is a P2, it hold the 5 space in the memory, that is 10 to 15, 11 to 15. After that 15 to 20 remain empty in this case. The 15 to 20 locations remain empty in the system, and these 5 memory spaces are vacant here. After that there is a P3, it's for the 18, it go from 20 to 38. It hold the 2 parts of the memory, it come from 20 to 30, that is from 20 to 30 and then goes to 30 to 38. After that there is a 2 points, 2 MB location which is vacant at there, that is 39 and 40. Last one is a P4. P4 is for the 7 location. P4 need the 7 MB to store. There is P4 that start from the 41 and goes up to the 47. After that, the three locations 43, 44, 48, 49 and 50 remains empty in that case. In the dynamic partitions, I have four different processes. First is a P1, it starts from 0 and goes up to the 10. Then there is a P2, it starts from 10, 11 and goes up to the 15. And P3 it starts from the 16 and goes up to the 33. Then at P4 starts from 34 and goes up to the 40. There is a 10 vacant space that is start from the 41 to 50. Now consider a process P5. If I have another process that is called a P5, it's come into the memory, and its size is 7 to 8 7 MB. Then in the case of static partition, even I have a memory location vacant more than the 7 MB, but we can't execute that process because that 7 MB is not present at a one place. It's present at the, it is scattered in the whole memory space. But in the dynamic partition, the 40 to 50 locations are empty, and we process that process from 41 to 47. And this is an advantage of dynamic partition. Now the fragmentation. Fragmentation is a process in which storage space is used inefficiently, reducing capacity and often the performance of the system. If I want to reduce the performance, it reduces the performance of the system. By fragmentation, it led to the storage space which is wasted by the system. In the previous example, here the storage space that is 16 to 20 is a wasted space, that is a fragmented spaces, and 39 to 40 it's also a wasted space by the static partition. That types of memory, that memory which is not used by any other process, is called a fragments, that and this is called a fragmentation. There are two types of the fragmentation which are occurs. First one is the external fragmentation, and second is the internal fragmentation. The fragmentation, the spaces left empty by the static partition is called internal fragmentation, and the fragmentation which are left by the dynamic partition is called the external fragmentation. The internal fragmentation is removed by using the internal programs, internal functions of the operating system, but the external fragmentation is reduced by using the disk defragmentation method. This is also given to the user for the removal. Now what is a contiguous memory location? Each logical object is placed in the physical memory at a consecutive addresses, one after the another. We place the each logical object one after the another in a sequence is called a contiguous memory allocation. Generally, memory is partition, and any process requesting memory is allocating a partition. On termination, process release the memory partition to a free pool of the memory. There are number of schemes which can be used for a system, but we can rate efficiency of the particular memory management scheme, like wasted memory, the amount of the memory wasted by the contiguous memory allocation, time complexity, the time taken by a object by a scheme to allocate the memory, and the memory access overheads, the time, the space which a memory access overhead taken. These three are the schemes, these three are the methods to rate the efficiency of the memory in a contiguous memory allocation. Now the static partitioned memory allocation. The memory partition are created sometime before the execution of the user program. These partitions remain fixed, and this approach is called a static partitioned memory allocation. The number and the size of the partition is fixed during the system generation by considering the three different methods. We can fix the size of the partition, or we can fix the number of the partition according to these three factors. First one is the capacity of the memory, the total space, the total area which a memory is holding, that is called a capacity of the memory, and the degree of the multi-programming, the number of the program, the largest number of the program which can be executed at a same time, and the size of the program, the maximum size of a program which has to executed at that time. Now the dynamic partition memory allocation. The memory partitions are created in the response to the process request. This approach is called dynamic partition memory allocation. The partition creation process goes on till the whole memory has been utilized. The each and every part of the memory is utilized. After till that the whole memory is divided and whole memory is given allocated to the processes. When a process requests for a memory partition, a process want a memory partition to execute to store the data, the memory management of the operating system create a suitable partition to allocate the process. It gives a suitable suitable place to place the process. It select the greater or equal size to process and allocate the memory and keep the record in the PDT, that is a partitioner description table. It keep the record into that table. Now the different algos which are used by the dynamic partition memory allocation, that are first fit, next fit, best fit and worst fit. Here is a first fit. Operating system searches the first partition, the first which is enough to store the process which I want to store into the main memory, that it enough to hold that process. We just put that process at that place. Next one is a next fit. The memory manager keep a pointer on a free list to store the process. Where the free list is present, where the next free list is present, there the memory is put. There the memory is allocated to the processes. Best fit. Memory manager searches a free list from the beginning to the end. It starts from the beginning and goes up to the end and find the smallest possible portion to hold that process. If the process is of 15, then it start looking for the 15 spaces which are consecutive but they are free, and 15 and then next is 16, the minimum possible portion to hold the process. The worst is the memory manager scan the free list and allocate the largest memory block to create the partition to store the process. Anywhere where the largest memory block is free, the process is stored at that place. Now the swapping. The process of suspended and preempted processes in the main memory with a new process is called a swapping. The process which is suspended by the main memory and a new process is given to the is stored in the main memory is called a swapping. When all memory partitions have been allocated and there is need to allocate a partition to a process, a suspended or preempted processes are taken out from the memory in order to bring the new process. Swapping is used to implement the multi-programming in the system. With the help of swapping, we consider the program to the multi-programming as which have a less hardware hardware support for the memory management. A system which have a less hardware support, where the hardware is not too much, the memory where we want to store, we have to store the data is not much more, its capacity is not much higher, then that place we use the process of swapping. Swapping is done by a module called a swapper. A swapper is a module, a program which done this process, that is called a swapping. Swapper done two different operations. First one is swap in and second one is a swap out. Any process which is come out from the main memory where the data is stored is called a swap out, and any process which goes into the memory is called a swap in. In this example, in this diagram I am showing you, there is a main memory which holds a operating system and the user space. User space consists of the various processes which we want to store in the main memory. In the second part there is a physical memory, that is a hard disk or something else. Here the two processes are, first one is process P1 and second one is the process P2. We are just putting out that P1 from the main memory to the physical memory. Here the P1 is goes from main memory to the physical memory and P2 is goes into the main memory. This is a process of swapping. One process is come out from the main memory and other one is come into the main memory, that is called swapping. Now the compaction, the process of reallocating all partition into one end of the memory and combine holes into a large free area is called a compaction. When we combine the free spaces present in the partition main memory at one end, that is called a compaction. When the memory become fragmented, the whole memory scatter everywhere, solution is to reallocate all partition at one end using that process, that is called a compaction. All the affected processes, the processes which are affected by this, are suspended and they are copied from one to another area of the memory. They are copied from one place to the another place. It can be performed whenever possible, whenever this thing we can do, or only when needed. Whenever it needed, we can also use that process, that is called a compaction. System compact memory when large free area is returned. Large free area which is returned by the system, then the system compact that memory, or when there is a failure to allocate a memory to the partition. If I want to allocate any process to the memory and there exists a failure at that time, system itself do this process, then known as a compaction. Now the different schemes to convert the paging, the virtual addresses, logical addresses to the virtual addresses, and first one is a paging. A paging is a memory management scheme that permits the physical address space of a process to the non-contiguous. In paging, physical memory is divided into a fixed size of partition that is called as frame. The physical memory is divided into the fixed size that is known as a frame. Virtual address spaces are divided into the blocks of same size that is called a page. We divide the virtual addresses to the pages and we divide the physical memory partition into the frames, the fixed size frames and fixed size pages. The page table is used to convert that, used for the address translation. We convert that physical addresses to the virtual addresses by using this page map table. The virtual address of the memory is divided into the two parts, that is page number, it's also given by a P, small p, and page offset, this is given by a D. Now I show you this by a diagram, how a paging can be occur. Here a CPU, at the starting there is a CPU, central processing unit, which generate a logical address. Logical address consists of two things. First one is a page number and second is the page offset. Page number is denoted by P and page offset is denoted by D. The page is converted to the frame. The frame is a part which is to store at the physical memory. Here the page table convert this page to the frame according to the spaces free for it. That frame is goes to the physical address and the offset of the logical address goes directly to that physical address. Now the new physical address is generated by the combination of frames and the page offset. We combine that frame and the page offset to make a physical address. That frame and the offset is goes to the physical memory to store that at that position. If that frame is 001, then it goes to the 001 location with that offset. By this we convert the logical address to the physical address in the paging by using the page table. Page table consists of two things. First number is page numbers, the different page number CPU can hold, and then at the second time there is a frames at the position, the places it have the frame. Each page corresponding to any number of frames. If any of the frame is not empty, any one of the frame is not empty, then it show that the whole memory, whole physical memory is full. Now the segmentation. Segmentation is another scheme to convert the physical memory, to convert the logical addresses to the virtual addresses. Segmentation is used at the largest for the large number of blocks, large number of data to convert that addresses. Segmentation is a memory management scheme in which address space of a single process is divided into the block. We divide the single processes into the block and that may be placed in a non-continuous area of the memory. And that paging, we place the data at